We will begin our study of ellipses. We are going to be combining two sections from the book to put the ellipses into one topic. So we're going to talk about ellipses that are centered at 0, 0, and then ellipses centered at HK. And what you may notice is that we are using a consistent notation of HK for centers of circles and the vertex of a parabola, and now the center of an ellipse. So let's begin. The definition of an ellipse is the set of all points such that the sum of the distances from a point to two fixed points, fixed meaning they are not movable, and these points are called the foci, is a given constant. Now, if we look at this visually and say that we have a focus here and a focus here, basically it's saying if we have decided that the sum of the distance between this and any other point, let's say is distance 1 plus distance 2 equals a number, that is the set of all points that makes that distance true. And then what happens is when you do this and run it around like that, it makes an ellipse. Now, there are two distinct formulas for an ellipse, and they determine which direction the ellipse will face. So the distinction lies in this middle box right there, with the a squared is larger than b squared. The variable that has the a squared underneath it means that the ellipse is going to be kind of like an oval, and it's going to be longer along that axis. So the equation on the right is longer along the y-axis. The equation on the left is longer along the x-axis. So I'm going to assign a point. I'm going to call this my center. There's my center. It is HK. And we're going to measure some distance, b squared, along the x-axis, and b squared is because it's under the x. But we're going to measure the square root of that, so b. And I'm going to say that we'll just make that 3. Okay. Now, if we're measuring along the y-axis, that has the a under it, so it has to be bigger than 3. So we'll make that a 4. If it was a 3, it would make a circle, and we don't want a circle. So we have 4 points, and it looks very much like the beginning of the equation of a circle. So what we're going to do is connect these dots right here the best way we can. And it looks circular, but it is actually called an ellipse. So it's going to be longer or taller than it is wide. The one on the right is actually going to be wider than it is tall because that a squared is larger. So I'm going to pick another center. We'll make it at 1, 1. And I'm going to pick this time my x to be about 4. And then I'm going to pick the b to be 2, or the b squared is 4, so b is 2. And like we did with our ellipse on the left, we will connect these dots the best way we can. And it's it's not too bad. Alright, so we have our two ellipses. Now the foci are going to be points that are in the cup for all practical purposes, kind of like in the parabola. So it's going to be in the cup. So basically what it's saying here is that if I measure the distance from the foci, let's pick a point. If we measured the distance from this point to the two foci and added those distance together, that let's say that I picked another point. Let's say I picked this point. That's going to be equal to that distance, and that's what makes an ellipse. Now, finding an x-intercept and a y-intercept for an ellipse is simply the same as finding it for a line, and an x-intercept crosses the x-axis. So you're going to let y equal 0 and solve for x. And you're going to, for the y-intercept, you're going to let x equal 0 and solve for y, and that tells you where your ellipse will cross the y-axis. Now, how to find the major axis is it wider or is it taller? You're going to look for the larger denominator. So that will tell you if it's going to be a wide ellipse or is it going to be a tall ellipse. So this is going to be the larger number. The minor axis is the other one. It's the smaller denominator. Okay, finding the foci, it looks a lot like the equation that we use, looks a lot like the Pythagorean theorem, but it's not the same. The distance from the foci to center is c. So just like our parabolas where we added a value of c to h and k, we're going to do the same thing with ellipses. And in order to do this, we will have, so the one that is wide and goes along the x-axis, that's where your focus is going to be. So there's a value of c. We're going to subtract from h, and we're going to add to h. And since the one on the right is going to be dominant on the y, it's going to be taller, then it's the y-coordinate that changes, and each ellipse has two foci. So here we keep the h the same, and then add and subtract this c from the y-coordinate. And it's important to know what the focus is and where they are, because that's really what determines what an ellipse is. And how do we find c? Okay, those denominators you have up there, you're just going to subtract them, and then you'll take the square root of c squared, and that's the value that you're going to add. And many times it's going to be a radical. Okay, so we're going to give the x and y intercepts of this ellipse, and we need to put it in standard form. If you noticed on the first screen that the equation for an ellipse is equal to 1, it's not going to be equal to 144. So to be able to have this be equal to 1, we're going to need to divide by 144. So I'm going to 9x squared divided by 144 plus 4y squared divided by 144, and it's equal to 1. And then we're going to reduce the fractions, and we end up with x squared over 16 and then y squared over 36. Okay, now this ellipse is centered at 0, 0, and the way I know that is that there's nothing subtracted from x and y. So just like the parabola and the circle, we're going to have a center of 0, 0. Now x and y intercepts. This is a special case I want you to observe for ellipses centered at 0. X-intercept, you're going to let y equal 0. So we'll start with that. And we'll have 9x squared equals 144 equals 1. Actually, we won't. We're going to use the simplified version instead of the middle of the road work. Anyway, we'll have x squared over 16, and y squared over 36, that's just 0. And we will solve that, and you get two of them. Plus and minus 4 is my x-intercept. That's also the amount that you're going to count from the center when we graph our ellipse. And then for the y-intercept, x equals 0, and we're going to do the same thing. We're going to be left with y squared over 36 equals 1, and then y is actually plus and minus 6. So that will help us graph. Now, down at the bottom, what are the foci? Foci is easy on this. You are going to subtract your two denominators, the bigger one first. We don't want a negative. So you'll have 36 minus 16, which is 20. And that means C is 2 square root 5. And you're going to add and subtract that from the value of the vertex, that is the major axis. Well, the major axis is y. So we're going to leave the x alone, subtract 2 square root 5 from 0, and then add 2 square root 5 from 0, and those are the two foci. Alright, we're going to go through a few steps on how to put an ellipse into standard form. The first step is to gather all variables on one side and constants on the other. So variables on one side, numbers on the other side. Next, you will complete the square of each variable. You will know to do that if you have say you have an x squared and then another term with an x in it. If there's only an x squared, you do not need to complete that square. You will divide the whole equation so that the equation is going to be equal to 1. And then if there are any fractions that need to be reduced due to dividing by the number, then you will need to reduce the fractions. Okay, we're going to begin here by putting our ellipse into standard form. Now, before we do this, I want to make a note about something that we are going to do. We are not going to do the step where we find the intercepts, so you can just mark that out. I want to focus on putting the ellipse into standard form, and I will also want to find the foci. So let's put this ellipse into standard form. We will begin by adding 16 to both sides because variables on one side, constants on the other. And then we do not need to complete the square because there are no additional variables. We don't have a y to go with our y squared. So we can just simply now divide everything through by 16. And we do that, we end up with y squared over 4 and an equation equal to 1. And as soon as you get an equation equal to 1, you know you're finished. You're in standard form. So now let's take a look at this. We have a ellipse that is centered at 0 because we don't have any numbers that are subtracted from x or y. And before we focus on graphing, let's start with the foci. So let's start with finding c squared. So c squared, we're going to subtract our denominators, and that gives us 12 for c squared, which means c is going to be, c is 2 square root 3. And we're going to subtract the 2 square root 3 from our vertex, and we're going to add it. But which coordinate do we add and subtract it to? Well, the x coordinate, the x on our equation, right here, has the larger denominator. So that is our hint that we're going to add the 2 square root 3 to the 0. So here we go. So our first focus is 2 square root 3, 0. And then 0 minus the other thing is negative 2 square root 3. And that's also 0. So let's graph this. So we're going to start with graphing the center. Now the center itself is not on the ellipse, but it is a great point of reference because we have to start somewhere. And let's begin with underneath our x. Underneath our x is 16, we're going to count the square root of that over. So we've got square root of 16 is 4. So we're going to go left and right in the direction of the x-axis. And then we're going to go up and down 2 in the direction of the y-axis. So, like that. And then all we need to do is to connect our 4 dots, much like we did with the circle, and now we have our ellipse. Alright, next example. We do have some completing the squares that we're going to need to do. If you look at the equation, I have an additional x, an additional y, and a number. So let's get everything together the way they need to be. So we're going to have a formula rearrangement here and a little skinnier pen. So we're going to rearrange. Let's get our x's together and let's get our y's together. And let's move Mr. 13 over to the side. I do want to point something out to you, that we don't complete squares with a coefficient in front of our square term. We're going to need to factor that. So when we factor out 4y, we're going to need to factor it out from this y also. So let's keep that in mind as we start with our completing the square. So we're going to start with leaving a space after my 2x for whatever happens when I complete that square. And we're going to factor out a 4. And we're also going to factor out a 4 from the 16. And we're going to leave a space also here too. Now, we have our negative 13 on this side. Now remember, whatever we add to the left side must be added to the right side. So, to complete the square of x squared plus 2x, we need to take half of 2 and square it. Well, that's a 1. So we'll add the 1 there. Add 1 over here also. Now, when we complete the square of the parentheses here, we've got a 4 here. However, we have a 4 on the outside too. So really this 4 and the 4 on the inside are going to be multiplied. So really what you're multiplying over here is 4 times 4, and I'm going to write the 4 times 4 so that we can see that it will be, we won't be leaving that out. So we're going to factor these. We did just complete a square, so let's factor it as a completed square, like so. And then we're going to combine all of those, and this just leaves me with a 4. Now I'm not in standard form yet because I'm not equal to 1. So the way I'm going to equal to 1 is I'm going to divide everything by 4. And the 4 just cancels over here, so I don't need to write a 1 underneath it, but if you need to, you can go ahead. Okay, so let's take a look at our equation. It's in standard form. No, there's not a number written under the y term, but that's because it's 1, and you don't need to write the 1, but you can if you want to. So my center, the number subtracted from x and the number subtracted from y. So negative 1 and 2 is going to be the center of my ellipse. Okay, so I'm not going to be finding the x and y intercepts, so we're just going to mark those out. Okay, so we're going to begin by naming the foci. And we need to remind ourselves of what our equation is that we found. So let's write this down, just so we keep it in mind. Okay, and we found the center to be negative 1, 2. So that's just for some reference. So, the foci, which axis are they on? Which one has the bigger number in the denominator? That would be x, so x-axis. And we're going to name our foci, so we're going to subtract the 2 denominators. Right here. Oh, not square root yet. And then square root it. Now, since the ellipse is spread out on the x-axis, we are going to be adding and subtracting square root of 3 from our x-coordinate. So that means our first focus is negative 1 minus square root 3, and we keep the 2, that doesn't change. And then negative 1 plus square root 3, and keep the 2. Okay, let's graph it. So we're going to begin with graphing our center, which is at negative 1, 2. And let's do our other 4 points. So underneath our x is a 4. Take the square root of that. We're going to count over 2 from the center in the direction of the x-axis, even though it's not on the axis. And then the y has a 1 under it, so we're going to go up 1 and down 1, and then we will connect our dots for this little bitty ellipse. And we'll correct this little drawing right there, see if we can make it look a little bit better. That's a little bit better. Alright, for our last example, we are going to do what we did with the other ones. We're going to put this in standard form, find the foci, and we're going to graph. So let's begin with rearranging our graph, or our equation anyway. Right now it's okay. I'm going to remind you that you need to factor, and where you're going to need to factor is right here. You're going to factor out a 4 here, but you're going to factor out a 9 here. So we have 4 times x squared minus 4x plus, I'm going to leave a space, factor out a 9, y squared plus 2y plus, and we're going to leave space, 11. Okay, now inside the x parentheses, we are going to add a 4, and why a 4? Well, I like 4s, but it completes the square. Now, that 4 is actually being multiplied by another 4 on the other side. So what we're really adding here is 4 times 4. The same thing with the 9. We're going to complete the square by adding a 1, but we also need to remember that 1 is multiplied by 9. So we're not just multiplying, not just adding a 1. So let's write all of this factored. And we're going to keep those 4's in that 9. So we have x minus 2 squared. And then plus 9 times y plus 1. That's also squared. And add everything up together on the right side, and you get 36. Okay, this is not in standard form yet, because we need to divide everything by 36. Because it needs to be equal to 1. Well, the 4 and 36 cancel for a 9, and 9 and 36 cancel for a 4. And now we're in standard form. How do we know? It's equal to 1, and that's how we know. Alright, instead of finding the x and y intercepts, we're going to find the foci. And remember, c squared, a squared minus b squared, almost a Pythagorean theorem, but not quite. So we will just subtract your two denominators, and then c is the square root of 5, and our major axis is x, so you're going to add and subtract that square root of 5 to your center coordinate. Your center coordinate is 2, negative 1. So you're changing the 2. So your first focus is 2 minus square root of 5, negative 1. And then you have 2 plus square root of 5, negative 1. Okay, finally, we get to graph. So we've already named our center. That was kind of important for finding the focus. So our center is at 2, negative 1, right there. So we'll graph that, and then we'll graph the rest of our ellipse. Now this 9, square root that, is a 3, and you're going to go over left and right 3 spaces. Right there and there. And then under the y is a 4, and then you square root that, and you go up and down 2. And then we're just going to connect. I missed that one. Let me fix that. There we go. We're going to connect our points. You can do better than that. So we put them back on. So erase them. Almost like a circle, but not quite. There we go. Alright, and that's how we graph ellipses.